In this lesson, I would like to show a shortened and frequently used form of the if statement. Let's go directly to examples. I have x equal 10 and y equal 20. I want to check if x is less than 100 and y is greater than 0. How such expression is evaluated? Let's become for a moment a bash. So we, the bash, try to evaluate the value of the expression. We read it starting from the left. Is x less than 100? X is equal 10. So yes, I am able to answer whether the entire expression is true. No, I cannot, because we have the and in the middle, so I need to check the first, and if it's true, I also need to check the second part of the logical expression. Okay, so is y greater than 0? Y is equal 20, so yes, it is greater than 0. Nice, now we have statement true and true, so the final result is true. Bash thinks the same because the returned value is 0, true. Indeed, to solve the equation we need to do all the steps, but what would happen if the left and right expression would be connected with OR? Let's analyze. We read from left again. Is x less than 100? X is 10, so yes. Are we able to answer whether the entire expression is true? Well, we can. Here we have alternative with the OR. When the left expression is true, then the entire expression has logical value of true, independently of the value on the right. It's enough that one side of the OR is true and the entire expression is true as well. There is no need to think and to analyze the expression on the right. Indeed, Bash is lazy and clever. It analyzes the statements from the left to right, and when finds that the logical value of the statement can be returned without evaluating following expressions, it will skip it and return the value. Good boy. Such logic and optimization is very practical. We will use it as well, but before we do, let's check another example. Suppose that I need to check if there is a user named Yoda on my system. One of the way how to check is to grab the file etc password, searching for text Yoda. That's a simplification of the problem, but anyway. Nothing was displayed. Knowing grep, that means that nothing was found. Nothing was found, so we have a kind of a failure, and when the command finishes with a failure, then the exit code is non-zero. That's our case. The command returns 1. The command will behave differently if I would search for an existing user. Such a user could be the one currently used by me, Wavel root. The user was found, so we have a success. The exit code is 0. Great. Now we are ready to connect the both examples. We know what is returned by some popular commands on Linux, and we know that Bash analyzes expression from left to right and finishes evaluation when the end result is easy to guess. Let's define variable user. I will assign a text Yoda to it. I will search for the user in etc password. When there is no such user, I want to display message informing me about that. If treating the expression as a logical expression, I could add here the OR statement and on the right put the command displaying message about missing user account. What will happen when the line is executed? The main goal of Bash is to check if the line returns true or false. That's alternative, so it's enough to state that the left or the right side is true. Bash starts from the left. It executes the grep command. But we are not lucky. The account for Yoda is not present on the system. The value on the left is false. What must be analyzed to return the value of the entire expression? Only the right side, and on the right side we have echo command. So Bash needs to execute it. As a, let's call it, side effect, we will see now the message displayed on screen, but internally echo returned 0, true, and evaluated the entire line as true. Bash is happy because it managed to deliver the logical value of the expression, and I am happy because Bash displayed the message about missing user. Indeed, the value returned by echo $? is 0. This 0 does not mean that the user exists, it only means that the alternative of two commands is true. Let's now see what will happen if the user existed on the system. I am changing the value of the user to vowel root. After starting the command, the grep has found the user. The line taken from the password is now displayed. Grep returned true, 0. Bash knows that an alternative should be checked, but the value on the left is already true, so no need to do anything more. The echo command was not started. The optimization on Bash side worked again. Why to do work that we don't need to do? Quite logical. The exit code for that alternative is 0, true. Someone could say, okay, but the current output from grep is making this order on my screen. I would rather expect to see message when the user is missing and nothing when the user is present. No problem. Output of the grep command can be sent to def null, and now the screen is clean. The exit code is 0. Nice. Okay, but is it possible to display a message only in case when the user exists? Yes, and that's easy. Just connect the left and the right side with an operator AND. Of course, the message that we are going to display should be different. This user exists. Now, from perspective of Bash, the situation is a bit harder. The left side evaluates to true, but that's conjunction. That's not enough to know the result on the left. To state if the expression is true, we need to know the value on the left and on the right. So now Bash goes and executes the right side, and as a side effect we see message on the screen. Good, but what will happen if we work with a non-existing user? Let's check Yoda again. In this case, on the left side the grep did not find such a user. The returned here value is non-zero, but this is conjunction. To have true as a result of the evaluation on the entire line, we would need to have true on the left and on the right. This time on the left we have already false, so it is impossible to change the value of the entire expression. Independently of the result on the right side, it always will be false. There is no sense in the execution of the right side. That's why the echo was not started at all. Let's go to another example. This time we will program the example in the script. Very often at the beginning of the script we want to check if all the parameters are correct or at least non-empty. Here we will test the variable computer name. Using a standard if statement, I am checking if computer name is empty string. Should this be true, I will display message and exit the script with 1. In opposite case, the script will go to next lines where another message is displayed. Finally, we end the script with the exit code 0. Let's check if the script works. The variable was indeed defined, so the script congratulates us the successful test and exits with 0. So it's time for another test. The variable will not be defined. Now the test ends differently. The output displayed on the screen informs me about error related to missing variable. That's good. The exit code is 1 that informs that we met an error. It works, but the code could be simpler. For such a simple test, we needed to write a few lines of code. If the script would accept, let's say, 10 parameters, then to check all of them I would need to have 40 lines of code. Horrible. Good to know that this test could be done in only one line. That's how to do it. First, using the test for computer name, I will be able to check if the variable is known or not. If this value is true, I would like to display a message. Thinking in the logical Bash way, when I want to execute the next statement, I need to connect with it using AND. Now, Bash will evaluate the expression on left, will find that it's true, but to return true to the user, it will need to go to the next expression on the right. The next expression will be echo command. The echo will return true, so the entire line will be true. But that's not the only operation that should be executed. I want also to exit the script pointing to error. How to do it? Generally, not a problem. It's possible to add more sub-expressions in one expression, so I will add here the next AND with exit 1. Bash will evaluate the first statement to true, and seeing AND will go to the next one. Echo will display message returning true, so Bash seeing AND would need to go to the next command, and this is exit. Here Bash will know all the values and will return true as well. On the other hand, if the value of a variable computer name would be set, then the expression on the left would return false. There is no possibility to get a value true in the conjunction where one of the sub-expressions is false, so there is no sense to run the next sub-commands. Bash would return false, but the echo and exit will not be started. Let's come back to the test. Now computer name is not defined. The script recognized the condition and displayed message on screen and next finished. So let's see what will happen when the computer name is defined. Now Bash stated that the left side of the expression is false, so the echo and exit were not started. This lesson presented how to build if statement in a short way. We used here a hidden knowledge, a trick utilizing the processing order and evaluation of different logical expressions.